SQL statements. And in the table of contents we have the data definition statements, data manipulation statements, transactional and locking statements, replication statements, prepare statements, compound statement syntax, database administration statements, and finally utility statements. This chapter describes the syntax for the SQL statement supported by MySQL, so we're gonna check out the next section. So we have the data definition statement, and here we have the table of contents. The first one is the atomic data definition statement support, so we're gonna skip all this. You can read it if you want, and we're gonna move to the next section. Here we have the atomic data definition statement support. MySQL 8.0 supports atomic data definition language DDL statement. This feature is referred to as atomic DDL. An atomic DDL statement combines the data dictionary updates, storage engine operations, and binary locked writes associated with DDL operation into a single atomic operation. The operation is neither committed with applicable changes, persisted to the data dictionary, storage engine, and binary log, or is rolled back even if the server holds during the operation. And here we have a note: atomic DDL is not transactional DDL. DDL statements, atomic or otherwise, implicitly in any transaction that is active in the current session, as if you had done a commit before executing this statement. This means that the DDL statements cannot be performed within another transaction. Within transaction control statements such as start transaction, ellipses, commit, or combined with other statements within the same transaction. Atomic DDL is made possible by the introduction of the MySQL data dictionary in the MySQL 8.0. In earlier MySQL versions, metadata was stored in metadata files, non-transactional tables, and storage engine specific dictionaries, which necessitated intermediate commits. Centralized transactional metadata storage provided by MySQL data dictionary removed this barrier, making it possible to restructure DDL statements operations to be atomic. The atomic DDL feature is described under the following topics in this section. So we have the supported DDL statements, we have the atomic DDL characteristics, changes in DDL statement behavior, storage engine support, reviewing DDL support. So we have all this information here. Well, as you can see, you have the supported DDL statements, we have the atomic DDL characteristics, the changes in DDL statement behavior, and here we're gonna see some examples. So let's go for the changes in DDL statement behavior. This section describes changes in DDL statement behavior due to the introduction of atomic DDL support. Drop tables, we have been using this. Drop table operations are fully atomic. If all name tables use an atomic DDL supported storage engine, this statement either drops all tables successfully or is rolled back. Drop table fails with an error if a name table does not exist and no changes are made regardless of the storage engine. This change in behavior is demonstrated in the following example, where the drop table statement fails because a name table does not exist. So as they say here, where the drop table statement fails because a name table does not exist, so create table 1, and we're gonna try to do it. So we're gonna log in with our credentials. So it's gonna be MySQL -u is gonna be root -p. I'm gonna type in my password, and we are gonna it's gonna be show databases like that, and we are gonna use the common queries database like that. And now we can type in show tables. So let's see which tables do we have. So we have T1, T2, and test. So we can say create table 1, and so let me see, we can type in create table T1, and we're gonna open close parentheses, and we're gonna have inside the parentheses C1, and then we're gonna have the integer. So we are gonna end up this statement with a semicolon. And T1, we already have T1, so let's use the drop table t1, okay, and also drop table t2, like this. Okay, so now I'm gonna just create a table t1 c1 integer. Okay, so I created a table, and let me see, drop table t1 and t2. So now let's just drop this table. So drop, okay, first of all let's show tables. So okay, so now we have the table t1, but we don't have the table t2. So let's drop table t1 and t2. Let's see what happens. So it's gonna be drop tables, and it's gonna be lowercase t1 comma space t2, and then we ended up with a semicolon. Okay, so press enter, and unknown table comment queries that t2, since we don't have it in our database comment query, so we don't have that table t2. And as you can see, if we type show tables, we're gonna have more tables. In our example, we have animals, child, facts, GMP, parents, all the MySQL playlist. Prior to the introduction of atomic DDL, drop table reports an error for the name table that does not exist, but succeeds for the name table that does exist. So let me see, let's try again. So let's create this table t1, so we have it. So okay, so we already have table t1. Let's drop it first. So drop table t1, and now what we are gonna do is gonna create a table t1, and we're gonna have the t1 and then the integer. So query okay, 0 rows affected, and now we can have the, oh, this is pretty much the same. So we are gonna try to drop table t1 and table t2. Okay, so it's gonna throw us an error, unable to drop the table t2 since we don't have it. Okay, show tables. Okay, if we put in show tables, we only have table t1 and test. Okay, so due to this change behavior, a partially completed drop table statement on a MySQL 5.7 replication source server fails when replicated on a MySQL 8.0 replica. To avoid this failure scenario, use if-exceed syntax and drop table statements to prevent errors from occurring for tables that do not exist. And we have the drop table, since we already use it. Drop table is atomic if all tables use an atomic DDL support storage engine. The statement either drops all objects successfully or is rolled back. However, removal of the database directory from the file system occurs last and is not part of the atomic operation. If removal of the database directory fails due to a file system error or server hold, the drop database transaction is not rolled back. For tables that do not use an atomic DDL supported storage engine, table deletion occurs outside of the atomic drop table or the drop database transaction. So we have that. We also have the create table, alter table, rename table, truncate table, create table space, and drop table space. So we have that. We also have the drop view. Okay, drop view fails if a name view does not exist and no changes are made. The change in behavior is demonstrated in this example where the drop view statement fails because a name view does not exist. So let's try it. Okay, so let's just type it in. Okay, so we're gonna go just here. I'm gonna make this one bigger, and we are gonna have create view, and this time is gonna be test that view uppercase letter A, and it's gonna be as select. Okay, as select, and it's gonna be from, so asterisk, and it's gonna be from the table lowercase letter t. We ended up with a semicolon, unknown database test. And if you type in show databases semicolon at the end, we have common queries db1 blah 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 MySQL. We don't have the table test. Okay, so drop view, we can type it in drop view. Okay, and it's gonna be test that view uppercase letter A comma test that, okay, that view, and it's gonna be uppercase letter B, like that. and again table unknown test that. Okay, so what do we it was okay. I instead of test that, I was with v instead of b, so it's like that. So drop view test that view a comma test that view b, but it's gonna be the same thing. Okay, so unknown table test that view uppercase letter a. Let me see. Test that view a comma test that view b. Okay, it's unknown since we don't have it. Now we can show full tables. Let me see, it's gonna be show full tables and test where let me see where it's gonna be table underscore type, and it's gonna be like, and it's gonna be inside single quotes view. We ended up with a semicolon and unknown database test. So since we don't have it, we haven't created it, but we can use instead of that database, we can create it. I don't know, maybe we can use common queries. Let me see. Okay, lowercase. It's gonna be like this, common queries, like that. And okay, show full tables, and it's gonna be common queries since we don't have this table test where table underscore type like view. So we have that. Okay, so we have it, but it's an empty set, so it's working. Let me see. We can pretty much it's gonna be like this. We're gonna create okay, we're gonna create a view, and it's gonna be in common queries. So it's gonna be common queries, and it's gonna be that view, and it's gonna be a, and it's gonna be as select, and it's gonna be from the lowercase letter t. Okay, like that. Query. Okay, 0 rows affected. Now we're gonna drop view, and it's gonna be common queries like this. Common queries that view, and it's gonna be uppercase letter a, comma, and it's gonna be again common queries. Common queries is the name of our database. I'm substituting since we don't have, or I haven't created the test database. Probably I had it at some point, but I dropped it or I just deleted it. So let's just keep moving. So now it's going to be common queries that view. We ended up with a semicolon, and common queries, unknown table, common queries. Okay, so it's gonna be drop view, common queries that view a, comma, common queries that view t. Okay, that's fine. So now what we are gonna do is just pretty much show full tables. So it's gonna be show full tables and common queries with table underscore type like, and then single quotes is gonna be view. And as you can see, we have the view, and here we have in lowercase letter a, but let me see if I selected it in uppercase letter a. Okay, so yeah, we have that tables and common queries instead of the table, or instead of the table, the database test. Instead of the database test, we are using the database common queries. Okay, so we have that, and in the second column we have the table underscore type, and then it's view. Okay, so prior to the introduction of atomic DDL, drop view returns an error for the name view that does not exist, but succeeds for the name view that does exist. So that's pretty much what we will be doing. And we also have partial execution of account management statements is no longer permitted. Account management statements is neither succeed for all names used or rollback, and have no effect if an error occurs. In earlier MySQL versions, account management statements that name multiple users could succeed for some users and fail for others. The change in behavior is demonstrated in this example, where the second create user statement returns an error but fails because it cannot succeed for all named users. So let's try it. So let's create user A. We're gonna type in here create user A, so that's fine. Query okay, zero rows affected. Now we're gonna create user A, and also we're gonna create user B. So create user A and then user B, we ended up with a semicolon, and here operation create user fails for user uppercase letter A, and then we have add and then the percentage sign. So we have that. Now what we can do is pretty much select, I'm just gonna grab it here. So we're gonna select user from MySQL that user where user like, and then in single quotes we're gonna have user and the percentage sign, and we're gonna end up this statement with a semicolon, and we're gonna have user, and the user that we have is gonna be user A as we have it here. So we have that. Prior to the introduction of atomic DDL, the second create user statement returns an error for the named user that does not exist but succeeds for the named user that does exist. So we're gonna do pretty much the same thing. We're gonna create user A. Oops, let's close this one. So let me see, let's move this one a little bit up. We're gonna have operation create user fail. Okay, so create let's try this one, create user A and user B. So operation create user fails. Okay, so let me see, we can just, okay, so we have create user A and then create user B. Select user from MySQL that user where user, okay, create user B. Okay, so what we can do is pretty much create user B individually like this. Now we can just pretty much do this, and we have select user from the MySQL that user where user, we're using the keyword like and then single quote user percentage sign, and in the user we have, in this table we have two rows, user A and user B. So we have that. Then we have this storage engine support, and let me see, so currently only the Eno database storage engine supports atomic DDL. Storage engines that do not support atomic DDL are exempted from the DDL atomicity. DDL operations involve exempted storage engines remain capable of introducing inconsistencies that can occur when operations are interrupted or only partially completed. So we have that. We also have the Eno database storage engine execute DDL operations and phases. DDL operations such as alter table may perform the prepare and perform phases multiple times prior to the commit phase. So we have these phases: the prepare, perform, commit, post DDL. Okay, so DDL logs are replay and remove from the MySQL.enodb_DDL_log table during the post DDL phase, regardless of whether the DDL operation is committed or rolled back. DDL logs should only remain in the MySQL.enodb_DDL_log table if the server is halted during a DDL operation. In this case, the DDL logs are replay and remove after recovery. We also have viewing DDL logs to view DDL logs that are written to the MySQL.enodb_DDL_log data dictionary table during the atomic DDL operation that involve the EnoDB storage engine. Enable the Eno database_print_DDL_logs to have the MySQL written. Write the DDL logs to the standard error or the stderr. So we have that. And okay, what else do we have here? So the structure of the MySQL.eno database_DDL_log table correspond to this definition. So they've given us this example. Okay, so we have the ID, a unique identifier for the DDL log recorded. We have the thread_ID, we have the type, we have the space ID, we have the page_no, we have the index_ID, we have the table_ID, all_file_path, new_file_path. This example demonstrates enabling ino database underscore print underscore ddl logs to view ddl logs written to standard error to create a table operation. So let's check it out. So set global, we're going to use the set global. So set global, and then it's going to be in lowercase letter ino db underscore print underscore ddl underscore logs, and we are setting it to 1. Okay, 0 rows affected. Now we're gonna, let me see if we can do that. We're gonna create table t1 c1 integer. The engine is gonna be set to the database, and the table 1 already exists, but what we can do is pretty much drop table t1 like this, and now we can use the create table t1 in the parentheses c1 and then the integer, and the engine is set to the database, so that's fine. And okay, so we have all this information here, and yeah, that's pretty much all that we have for the atomic data definition statement support.